Okay, so carrying on from the previous video, we're going to be looking at now where the data is situated. And so we can quantify or explain this by using something called the median, the lower quartile, and the upper quartile. We looked at the median in the previous video, right? It just represents where the middle value would be, and essentially just tells us where 50% of the data is before that and 50% of the data is after that value. Now the lower quartile, sometimes known as Q1, represents 25% of the data, so i.e. it just represents this part here. And the upper quartile, it represents 75% of the data is below that value and 25% is above that value, so it's known as Q3. And the way we work it out, well, Q2, the median, remember we have to do n divided by 2 and then round up if it's a whole number, and then if it's a non-integer, if it's a whole number, round up by 0.5. If it's an integer, if it's non-integer, we round up to the nearest whole number. For the lower quartile, we just have to do n over 4 this time, okay? Because we're looking for the 25th% value. And for the upper quartile, we're looking at 3n over 4 because that's going to represent the 75th% value in the location. Now, this is the case when we're dealing with discrete data, as you can see here. Discrete data being when the values of the data are just individual values, individual numbers. When we're dealing with continuous data being when we have a value or like a class, so it can be any value within a lower limit and upper limit. Then we have to do something called interpolation, which we'll look at in more detail later on. All right, so let's look at this part here. So this is the discrete data because each data value is just its own individual value, right? So that means we're going to have to find the median and upper and lower quartiles for this. So first things first, you always want to write them in ascending order. That's the very first step you should be taking. Right, so as we said, you have to write them in ascending order first. Now for the median, remember, I'm going to write as Q2. Sometimes you might see it as M for the median. It's the n over second value, right? So n being the total number of terms, in this case is 16, so 16 divided by 2 would be the 8th value. Remember for discrete data, if it's a whole number, we always round up by 0.5, right? So we're actually looking for the 8.5th value. Right, so this is the 8th value here, this is the 9th value here. So we're looking for the value in between that. So the median would be 1020. That would be the median value. Right, for the lower quartile, Q1 is n over 4 this time, right? Because it's the lower quartile. So n still being 16 divided by 4 is the 4th value. But remember, because it's a whole, it's an integer, we have to round up by 0.5 to the 4.5th value here. So 1, 2, 3, 4. This is the 4th value, this is the 5th value. So we're looking at the value in between that, which is still going to be 1017. And finally, for Q3 being the upper quartile, is remember it's 3n over 4th value. So 3 times 16 divided by 4, which will be the 12th. Once again, because it's a whole number, we round up by 0.5. 12.5th value here. So we have 12 and the 13th value. So we're looking for the value in between that one, right? So that's going to give us 1024.5. Okay, so as long as you make sure that you find the right nth value and then we round up accordingly, then you can find the lower, upper, and median for any discrete data set. Now, as I said, it differs when we're dealing with continuous data. Continuous data being an example where we have maybe like 100 to 200. So it can be any value in between that, okay? So it's not discrete anymore. In this case, we can't really do the method we used in the previous example. We have to do something called interpolation. Now, what interpolation is all based upon is just basically, you can just think of it like a ratio, essentially, okay? So I've drawn out the number line here, and I've written out a couple of values. So on the above the number line, I've written out the lower class and the upper class. This just represents the highest value, the highest value the value can be, and the lower class is the lowest one. So in this example here, the upper class would be 200 and the lower class would be 100, like this. And then we're trying to find this Q2 value inside here, okay? Right, below that, I've written out the frequencies. So this is the upper frequency and this is the lower frequency, okay? And so we're going to try and find the n value here. And so essentially, you just have to imagine it being ratios, okay? So if I was to draw basically this length here, Q2 minus the lower class, I'm going to write the lower class. That must be equal to this ratio here, right? Or this length here, which would be m minus the lower frequency. And that's going to be all over the total length, in this case for the upper one, this length here, which would be upper class, I'm going to write this upper class minus lower class. And that's over the length of this bottom part here, which would be upper frequency minus lower frequency. Okay, so essentially we're equating the ratios of the above and the below together. This might seem a bit confusing in the beginning, but as we practice some examples together, it might hopefully get a bit more clearer for you guys. Right, so let's look at this one here. So we have the weights of 31 Jersey cows which are recorded to the nearest kilogram. The weights are shown in the table. Find an estimate for the median weight. So first things first, it's already given in ascending order, right? Because it goes from 300 to 549, so it's in ascending order. So we just have to go straight for n over second 2 value, right? So n being 31, so 31 over 2, okay, which is the 15.5 value which we're trying to find. Now for discrete data, what we did was, if it's a non-integer, we round it up, right, to the nearest integer. When we're dealing with continuous data, it's very, very important to notice that we don't have to round up at all. We have to use a specific value, okay? So that's the difference, that's the initial difference between continuous and discrete data. Right, next step is now to locate what the 15.5 value is going to be. So there's going to be 3 here, there's going to be 6 here, so in total there's going to be 9 in between here, right? So the next value here will be 19, so the 15.5 data will be within this class here. So we know it's going to be between 400 and 449. That's where we know it's going to be beside. Now I'm going to draw my number line. So I'm going to draw my number line like this. Okay. Now on the top, I'm going to draw the class. So the minimum class is, it looks like it's 400 here, right? But as you can see, the previous highest one is 399. So there's a gap between 399 and 400. So we have to make sure we fill that gap in. So we go 0.5 below. So essentially the lower one would actually be 399.5. Same thing for the upper one. It stops at 449 and it starts at 450. So there's a one gap in between, right? So we have to actually add 0.5 to that. So it'd be 449.5. And then we're going to write this as Q2 because that's what we're trying to find essentially. Now on the bottom one, we're going to deal with frequencies. So what frequency does it start off with? Well, we said before, there's 9 before that, right? So it starts off with the 9th value, so 9 before. And there's a total of 10 inside this class, so the maximum will be 19. And we're looking for the 15.5 value like this. So this is a number line you should always try and draw in the beginning. But now it's all about ratios, okay? So looking at the top values first, the length here will be Q2 minus 399.5 over the total length, which would be 449.5 minus 399.5. Okay, that's the ratio of the top. It should be equal to the ratio of the bottom. So the length here will be 15.5 minus 9 over the total length, which would be 19 minus 9. And now it's just a matter of rearranging. Because after you've got this equation, the rearranging part is not too difficult. It's actually getting to this equation first, which might be a bit more difficult. Q2, I think we get 435.6. So this is basically what interpolation is. Right, B, let's look at the lower quartile. So same thing, first things first, what we need to do is we need to find, this is lower quartile, we write as Q1, and it's not n over 2, it's n over 4. So that's still the same as the discrete data set. So we do 31 divided by 4, which is the 7.75th term. Now it's different because we don't round up, we just find that term here, right? So we need to locate what class it's going to be in. Well, there's 3 values here, so it's not going to be in here. Together that's 9, so it has to be within this term here. So it's going to be in the class 350 to 399. Now I'm going to draw my number line. So like this, just randomly like so. Now the lower value was 349.5 because remember there's a gap in between here. And the upper one will be 399.5. And we're trying to find this Q1 value like this. We have to look at the frequencies now. So it starts up at 3, there's 3 values before. And then there's a total of 6, so it's going to be 9 values at the end. And we're trying to find the 7.75th value. After we've located this, now it's just a matter of just doing ratios. So it'll be Q1 minus 349.5 over the total length at the top, 399.5 minus 349.5 is equal to 7.75 minus 3 over 9 minus 3. And then you can rearrange to find your Q1 value like this. It's the same method for see the upper quartile, okay? So upper quartile, Q3 we'll call it, is the 3n over 4th term, right? So it'll be 3 times n being the total number 31 like before, over 4, which would be the 23rd.25th value we're trying to find. Remember, we don't round up, we just find this exact value. We just have to locate what class it's going to be. Well, 23.25th value is actually going to be in this class here. Okay, and then we just do the 450 to 499. And we just do the same thing. We draw your number line and then you equate the frequency together and then you work out for Q3. Okay, so this is basically what interpolation is. It just takes a lot of practice to just get used to the method itself. But once you get used to the method, then it should be fairly simple and you should be able to deal with all the exam questions that they give you. Right, finally, we're going to be looking at percentiles. So what a percentile is actually very similar to a quartile. So remember, median represents Q2, right, which represented 50% of the data before that. And so the median was, if I draw this number line here, it's actually this value here. This is the median value here. And as I said, it represents 50% of the data being before that and 50% of the data being after that. Well, there's something called percentage. For example, we might have something like P8, which represents the 80th percentile. And this just means that 80% of the data is before that value and 20% is after that value. So P80 would be roughly here. Same thing as like P10, this will represent the 10th percentile and will represent where the value at which 10% of the data is below that value. So P10 would be this value here. We looked at Q1 and Q3 earlier on, right, which were the lower quartile and the upper quartile. And lower quartile meaning there's 25% of the data before. So that's essentially the same thing as P25. And the upper quartile is the same thing as P75. So it's just a matter of just lower quartile and upper quartile have a specific name because they're more useful, but percentiles can also be useful for other information. And so that's how we find each individual one. Right, the way we go about finding it, well, we go let's say Pn as a percentile, then we get n over, let's say Pa as a percentile, so A over n, A over 100 times n value will be the one we would have to find when we're trying to find these percentiles. We'll look at this in more detail in the next video. Alright, so we're going to look at this in more detail in this example here. So we have the table which shows the recorded wingspans in meters of 100 endangered Californian condors. Estimate the 80th percentile. Okay, so first things first, P80. Now, as I said in the previous equation, PA would just be A over 100 times n. So in this case, A is at 80 divided by 100 times n being the total number of values. So it's just the sum of each one, which is actually 100 itself. So we're actually finding the 80th value. Okay, and once again, because it's a continuous data, you can see by the classes, we're going to have to do interpolation. So looking for the 80th value is going to actually be within this range here, this class here, right? So let's draw a timeline. Right, so the lower value, note in this case, it goes from 2.5 to 2.5, so there's no gap in between. So the lower class boundary will actually be 2.5, and the upper boundary will be 3.0. We don't have to add 0.5 like the previous question. And we're trying to find P80. Right. On the below that, we're going to look at the frequency. So adding up each individual frequency, we have 57, so 61. And then we're going to have plus 28 will be 89. And we're looking for the 80th value like here. So we have the class on the top, frequency on the bottom. And now we're just looking at ratios, right? So looking at the top first, P80 minus 2.5 over 3.0 minus 2.5. Is equal to 80 minus 61 over 89 minus 61. And if you calculate that, P80, you get 2.84. Okay, so the only difference between, the interpolation steps is the same, right? The only difference between looking at percentiles and quartiles is just initially trying to find the initial value, where it's going to be within the classes.